Hi, good morning, and thank you for joining me in my shop. Today is March 28th, and some freezing rain is coming here today. So I have on my bench one of the oldest radios I've ever had in here. I've only had a few radios of this kind of vintage. So this is from 1920, 25, I think. And this is a fairly early commercial radio that was available in the store. You could buy it. You'd have to pay a pretty big buck for something like this. Save up your pennies from your job to get one of the newfangled receivers. So this is called a TRF radio, tuned radio frequency radio. This predates the modern super heterodyne sets. I call them modern, but I guess they're not terribly modern anymore. But just a few years after these were being produced, a different technique was developed and then utilized in radios from then on. The new technique resulted in less dials to tune. To tune this radio, you have to tune these 3 dials, and you have to tune them correctly for the signal to go all the way through the radio and come out the speaker. And there is no speaker here. These are also controls here. These are rheostats that control the heater current in these early radios. The way they controlled the volume or had some control over the vacuum tube was to control the current going through the heater, make it hotter or make it less hot. And so that's how the volume was done. And also you'd want to adjust these for the best quality of sound to come out of the radio. This one is adjusting the heaters on these 2 tubes, and this one's adjusting the heaters on at least 2 of the last 3 tubes. We'll take a look inside here in a sec. So there's another control here, and this is a tuning the antenna slightly control. And I think this is connected to a auto transformer inside, and you're just changing the number of turns in the small part of the auto transformer. So that's about it. On-off switch. That would be on. That would be off. And let's just take and this big box here. So this radio would normally be battery operated. So you'd have 2 batteries, or maybe 3 batteries. You'd have a large low voltage battery to drive the heaters, and then you'd have a high voltage battery or a couple of them to produce the high voltage to run the tube. So you need about 100 volts or so to run the tube plates. That's a hassle having batteries. You had to go get the one battery that's running the heaters would run out all the time because the heaters are drawing so much current. So you'd have to get this battery replaced, or typically you'd use a rechargeable battery. You take it down to the radio store, leave it there for a couple hours. They would charge it up for you, and then you can come back with your heater battery and play your radio again for I don't know how long, hours I'm sure. Okay, in 1925, how many stations were there to pick up here in North America? There was quite a few, more than a handful by 1925, but I don't know for sure how many. And they'd be dotted around the United States. In Canada here, there's also very early radio stations, but I couldn't tell you too much about it. There's sort of a very similar thing was going on in Canada and the United States at that time in terms of the development of radio technology. One of the primary inventors of radio, a fellow whose name is not well known, a guy named Fessenden, was actually a Canadian working in the States. Now there's a familiar pattern, a Canadian working in the States. Okay, let's take a closer look at this radio and start thinking about what can I do with it. Oh, I never finished explaining this box, but I will explain this box over here. This certainly looks home built to me. It just looks like you've just taken some wood and banged the box together. It has a regular plug on the end of it here for plugging in the wall, so we can take a really good guess that in here is what is necessary to convert the power coming from the outlet into the power that this thing needs. So there should be a transformer in here to produce the current for the heaters, and then there has to be a transformer to produce some high voltage, and then a rectifier tube has to be in here too. Wow, this is good. This will be the starting point for us, I think, to investigate. Lay it down like this. I just don't think this is a commercial thing. I mean, maybe it is. So this would be there's a term for this, battery replacer. Battery, I can't think of the name of it now. I have a couple more out in my garage, but they're not home built. This really does appear to be just home built. So we have this big honking cable coming out. This will be the original cable. For some reason there's another, this is basically speaker wire coming with it. Speaker wire. Is that for a speaker? Where do you hook up the speaker on here? So there's probably some terminals on the back. Okay, now for convenience for me, I'm going to set this right on top of the radio. Say, why is that convenient? Because all these wires here are a problem. Let's look at the back of the radio now. So we do see radio speaker, black lead, just says black lead. Here it says red tracer lead. And what's going on with this wire? So one lead is broken off, whatever this is. What is this? This looks like a couple of nails shoved in there. That's what it is. It's a couple of nails. So we're going to pull that out. We don't need that. Is there a speaker inside this box? Why would somebody want to run the speaker wires up here? Because maybe these terminals on the top here, these two screw terminals, maybe these go to the speaker. And that's how he did it. maybe, but we'll leave these open. You managed to solder it to the top of a nail. How did you do that? Okay, over here we have ground and antenna, very, very clearly labeled. Can't go wrong. What's in there though? What more of those kind of pin? Well, this looks like where cables come through. There's no socket. And inside are some binding posts, I believe. But the speakers, oh, that's interesting. Let's take a look. I'll switch cameras here. We'll get a closer look. So we're going to look in the radio speaker, red tracer lead. What are they talking about? So there appears to be, my camera doesn't like this very much. Well, there's a couple places for those pins to go in, obviously. You can kind of see them there now. There they are. Is that bottom piece of metal is a spring-loaded pressure. Puts pressure on the connector, or whatever it is, the nail you shove in there. Okay. Inside here, you can't see much. It's just a post in there. I believe that's what you're seeing up there. This is the connector post. Okay, well, let's look inside now. Not so handy. I put this on top. I'm trying to avoid working these wires very much. Okay, we'll put this. This box is very unbalanced weight-wise. All the weight is right here. This wire is pretty old itself. It's quite stiff. Just looking for any cracks. It's been bent like this for ages. No, seems okay. Okay, let's take a look inside. this radio has little thumb holes here for lifting the lid. Very thoughtful. Okay, so we have a tag here. Let's take a look at the tag. We'll use the other camera. We'll take a close look at what it says. Atwater, Kent. So I found out yesterday this is a guy's name. I thought it was a couple people, Mr. Atwater and Mr. Kent, got together, but no, it's one guy, Atwater Kent. And he has actually a third name. He has another name out the front here, which they didn't use, like Bill Atwater Kent, something like that. Not Bill. Excuse me. Made in the USA. AK. I've never noticed the symbol AK like that. Model number 20. Use only 1/4 amp fuse tube, so ampere tube. So what they're saying is use vacuum tubes that only draw 1/4 amp on the heater. I mean, there were a lot of vacuum tubes to choose from back in the day here. This one, every tube is the same tube in this one, and O1A. Serial number, look at how many. 247,000 of these. So Atwater Kent, interesting guy. I'd suggest you read a little bit up on him. One of these literally self-made people, dropped out of school early and was just fascinated by this stuff and managed to put together a huge company. They built a gigantic factory. It's hard to believe. There's a picture of it. How gigantic this thing was. How many football fields it would cover. Where these radios were being made, along with his other models, in Pennsylvania, Philadelphia, Pennsylvania. Is this right there? Philadelphia, Pennsylvania. That's right, isn't it? Okay, well that's the name tag. Now we'll take a look inside here. So this is typical of these radios. They are basically coils and tubes. Coils being transformers. A tube. Wow, so very interesting. The coil designs, this is where the engineers were focused at this time, making these coils. So they've done lots of experimenting and whatnot to come up with these very specific designs. Look like some debris right down on the bottom there. They're a little fragile, but they're in these wooden boxes, so generally they're in good shape. Oh, what's this? I didn't notice this before. Oh. This has got to be, this must be the antenna, I guess. Well, shove it in there down among all these coils. And very carefully wound. Spacing here is absolutely critical. It's not just based on the insulation around the wire. Not too sure what I'm going to see here, but I thought we should take a look. Got something written on it. The tube doesn't look very good. The other side of it that we're looking at is blackened, very blackened. Let's pull this guy out. Oh man, so I don't want to pull on the glass bulb to pull the tube out. Jumping ahead here a little bit, but you know, whatever catches my curiosity. The way I approach these projects, I try to approach them in the most fun and interesting way I can think of for my own sake. So let's see if we can get it out. Yeah, there it comes. 201A. So just another 01A. 7-point inspected. 9/11. 36. So in 1936, this radio was still being used. Really? Or this has come from another radio. It's got a serial number on the vacuum tube. Stamped in 1033 or something like that. What's that say? New. Okay, here we go. New Haven. Is this? No. Well, he's written the date. And what would he tend to write? New. I can't read it. Yeah, I don't know what he wrote there. Look at that. Isn't that cool? Look at the tube symbol in the middle. That's just a little tiny thing. You can really hardly see it unless you look at it with a camera. Okay. Yeah, that tube's okay. But look at this huge black spot or darkened spot right. I can't see what I'm doing. Right here. You can see it quite clearly in this image. There's a spot there. Does that indicate a defective tube? It's not a common thing to see this kind of discoloration. So maybe this tube is no longer okay. I don't know. Well, it's going to have to be okay for now. I'm going to put it back in. These tubes have a little pin sticking out of the side here. And that pin slides into a slot in the socket. And then you push down, you're pushing the pins against the spring-loaded contacts, and then you twist it like a bayonet arrangement to lock it in. So the tube is locked in, pushing on the 4 contacts underneath. There's another one with some stuff written on it. What's this one say? Okay, 2. It also has a spot on it. Radiotron UX201A. All kinds of dates on it here. It must be patented 1911, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 is the last year written. 24 right on the bottom of this plate. So this might be from, let's suppose this is from 1924, and that's over 100 years old. It's one of the reasons I'm a little anxious about working on one of these really old radios. There's a lot of, I think there's a lot of these around. A lot of radios from the 1920s around, and they're all in preservation hands now. So whatever exists in the world is not going to disappear. Like this one will never end up in the garbage, I'm sure. When it leaves me, it will go somewhere else and continue on as a piece of interesting antique technology. Great. Okay, I'm not sure what to do next, so I'm going to go get my cup of coffee and ponder the situation a bit, decide what to do next with this very interesting radio. Is there a chance we're going to hear it today? Kind of doubt it, but we'll see. Okay, I think the next step along the way here is to open up this box and look inside, see what's in there. Two screws here, 2 screws there. This does look like a lid. Oh, it's got side screws in it too. Does not look like a lid. Maybe we take the side off. Take one side off. I think that's a better move. Take this out here. Well, let me take the screws out off camera here. Some of the screw heads are full of paint and very hard to get a screwdriver in, which gives me the impression that I'm the first guy to take these screws out since the last guy put them in. There we are. What have we got in there? Oh my gosh, look at that. That is quite a setup. Holy smokes. And pretty modern too in some respects. Boy oh boy, look what he's done here. So he's built an entire power supply. Got the filter capacitors. It's got 2 different rectifiers here. Very even though they're hanging out here, it's solid. What a job. He's done quite a job here. He's made a terminal pad, or he's used a terminal pad to connect to the cable. Here's the audio. This is an audio output transformer. So what he's rigged up here is like these radios normally feed into a high impedance speaker. I have one, so we can use a real speaker. But as an alternative, you could run the output through a transformer to change the output impedance and lower it way down from a few thousand down to a 10 or 20, and then feed it into a more normal speaker, a more modern speaker, if you like. So this is an advanced step from radio technology sort of point of view. He's made this connection with one of these. It's not soldered. That looks okay. So, is there anything in here that I would look at and go, oh my gosh, that's a scary thing? Here's the, so this is the power cable coming in here. Pull this back a bit. Comes in, loops up, goes through this connector. The other end, there's another connector on the other end, just down here. Connects to a couple wires that then run into this huge transformer. Big transformer. You can't see any information about it. But nobody did this without knowing what they were doing. Whoever did this, they knew exactly what they were doing. And I think if you go way back to the late 1920s, early 30s, these things were really popular. This kind of arrangement. Not this one in particular. This is a home built job for sure. But I have a couple of commercial ones that were battery... I forgot the word. Battery displacers. I've forgotten the word for it. They were very common. So you'd have one of these radios, and then one day you get your money together and go buy a battery displacer. The word's just on the tip there. It's just battery. I just can't quite think of it. So how do we go about now making sure this is all working? Do we even have to do that? Is there any reason to think there's something terribly wrong here? Everything's tight. Everything looks good. He's used real high wattage resistors in here for whatever he was doing. I guess those are the... he's got a couple in series here. These are actually in series. Can you see how... let me get the other camera going here so you can take a look at this in a little more detail. Because the guy who did this was thinking. I think he was thinking. So you see the high wattage resistors here. The chances are these are my camera should focus here in a moment. These should get warm. Oh, there we go. A little bit warm. So one of the ways you deal with a hot resistor is you use extended leads, or you leave a lot of lead, so the heat has to travel all the way up this wire to get anywhere. Same thing here. And he's done these two together. If he'd done them short right across like this, then he'd lose this cooling benefit here, and maybe it's not much, and maybe it's in the end not really effective the way he might imagine, but look what he was doing. So yeah, I think this is all signs that whoever did this really knew what they were up to. And what are these light wires for? These red ones. Where are they going? They're just disappearing down in behind there. Oh, they're this must be going down to like a positive. You know, they're going down, and I think they're showing up way down here again. Something like that. Well, I'm pretty impressed. Somebody worked hard on this. Okay, now let's take a look at the situation with the radio. Figuring all this out one step at a time. We assume that this is all done correctly, and that if we basically plug this in, turn it on, this radio is going to come to life if I go get my speaker. There was nothing we saw anywhere that seemed to be out of sorts, except some of these tubes don't look very healthy, but that's just how they look. How they are, we don't know. So I could test those tubes, or we could just fire the unit up. What would be the worst thing that could happen if a tube is defective? if it has a short in it between the heater and the cathode, or heater and the cathode, that might result in something ugly going on. Maybe we should test those tubes. Yeah, why don't we do that? I've got a million tube testers. Why don't we get one out and test those tubes? Well, I brought in my horn speaker. I have the horn itself is actually a modern remake, but at the base is an actual antique speaker at the base there. So that should work okay with this set. Think for a minute now. If he's got this connected through this output transformer already, and it's already done, and let's see here. The speaker connection is over at this end here. Of course, that's at the output end. Of course, it would be there, and can't really see what he's done, but we can assume, you know, maybe a better way rather than starting with this. Why don't we try what the guy set up here, since it looks so easy to do. Get the two speaker terminals here, and I've got a speaker here. Let me just reach up here. So this is just a regular 8 ohm speaker, a little higher on the wall. You see it up there. And I'm going to put this on here. I think this is a better approach. Yeah, looks like I'm going to try and make this thing work. Yes, it does. Oh, I was going to test the tubes. Well, I can still do that. You have to sort all these things out anyway. Doesn't matter what order you do them in. So we have the speaker thing ready, and I need to test some tubes now. Rather than use an old tube tester, for crying out loud, they're all old tube testers. I'll use this one, I think. Let's see if we got an OA. Like, this is an old tube, so these tube testers may not even test it. I cannot roll the roll chart. Oh, it looks like it's coming. Oh man. Okay, a little bit of a problem there. Let me see if I can find a manual for that tube tester. Okay, can't roll the roll chart far enough to get to 01A. Weston 981. Property of CFOR radio, January 29th, 1960. I've got their tube tester. One of my other tube testers came from a uranium mine. Yeah, the El Dorado uranium mine. So in here, there it is, 01A, right there. There's the setup for it. Perfect. Okay, let's do that. 01A. Filament voltage is 5. Signal level is 2. The bias is 22H. The selector's 63500. 63500. And 7,000 on the bottom row. 7,000. Sensitivity 42. And D for the plate. D for the plate. Has a note here in the remarks, F. What the F indicates is when you do the short test, you get around to position number 1, it'll indicate a short, but it's not a short. It's just what happens with some tubes in this tube tester. Reject point 520. So on this test, the pointer should rise above here. Now we are having trouble seeing the scale there. I'll fix that. So okay, first tube we're going to check is a what? It's okay. Just reading what's on top here to be I'm absolutely sure. 201A. So the 2 indicates the manufacturer. 01A is the actual tube number. It's going to go into the socket here. It's in. You can see it'll light up immediately. These tubes operate immediately. They heat up immediately and they begin operating immediately. They don't take time to warm up. Okay, so we'll do the short check on it. There's the short on position 1. Oh, you can't see that, can you? You cannot see that pointer. Okay, so a real clumsy way to fix that is to kind of arrange a little bit of a shade up here. That's a little bit better. Okay, now for the test itself. Again, got to come above 520, wasn't it? It's not on here. It's on here. 520. So just above where my finger is. There we go. Oh, she's a beauty. Okay. First tube, good. That's a 100-year-old tube. Well, it probably isn't. It's probably a replacement. It's probably from the late 20s, but who knows exactly. Oh, sometimes it says on it, doesn't it? The date of it. And these tubes could have easily gone from one set to another. They could have lived in different radios at different times. So it's written down here, 201A, Radiotron UX. Okay, put that in. So two pins are fat and 2 are thin. And that's the control. That's how they used to control which way the tube goes in. Started glowing immediately. Short check. Nope, all good. And we test well above. Now these tubes sit around for a long time, as in decades, not being operated. The materials inside the tube can vaporize a tiny amount of literally atomic material or gas into the tube, and this can interfere with its operation. There's something called a getter inside the tube, which is supposed to collect some of this stuff. It's really involved with reducing the vacuum inside it. The getter would be at the whole top of this bulb is shiny because it has this getter material in it. But nevertheless, over a long period of time, some gas can form in the tube. When you first put it turn it on in a radio or a tube tester or something like that, the condition inside the tube could be poor. And over time, when the tube heats up, especially when the glass gets hot, the getter can be reactivated or becomes active. It can start getting all that stuff out of the vacuum in there. So I don't know the details of this issue. I don't know if it's even worth talking about. It's just something that's going on in these old tubes. So one solution is just plug the tube in and operate it for a period of time. Well, if that's the solution, then there really isn't a solution, is there? Because you just plug it in and operate it. But over time, so you might get like there might be some ions in there, and you might get grid current, maybe. I don't know, and maybe the stuff flushes out after a little bit of time. I don't really know what I'm talking about, but nothing new in that. You know, if you wait until you know everything, you won't get anything done ever. And us human beings, we're really good at taking partial and conflicting information and sorting through it. We're really, really good at it. 201A. Let's go with another one. Heat it up immediately. Also, the glow in these tubes also is not dull red. It's actually a yellow color. The heaters are running at a higher temperature because they need the higher temperature to throw the electrons off, because it's just wire in there. The later tubes came with coatings on the heaters, and the coating is favorable for emitting electrons, and so at a lower temperature they can flush out a lot of electrons, but these guys require a higher temperature. So the filament is more like a light bulb, or like an old style light bulb. And I know you can hardly see it. Okay, here we go. Any shorts in this tube? No shorts. And the test. Very good. Surprising in itself, isn't it? But think about it. I mean, how many things are there that are going to be preserved because they're inside of an evacuated glass bulb? Here's one. Technology tucked away inside an evacuated glass bulb. So here we are 100 years later, and it's still pretty much the same thing it once was. Yeah, you know, it's a little like old records. You know, records are still around, vinyl records are still around. Even the earlier 78s from the 1920s and earlier, still around. How's your VCR doing? So there's old technologies that, by virtue of their nature, are preserved. I mean, not the least of which is this big honking wooden box here. That alone is enough to extend the life. Uh-oh, this guy looks totally different from the other bulbs. See, it's gone all kind of whitish in here. So what this might indicate is the getter I was talking about has been getting stuff a long time in this tube, and it's gotten out. It's got no more get. It's got up and left. So it's possible that this is a gas-filled tube now. It can't clear itself anymore because the getter is spent. But I don't know for sure. I mean, it says okay. And this is a... just want to read it. I think I see it there. And there aren't many tubes from back in this time. The UX2018 in a TRF set. They're all just full of these triodes. Later, when you get the more complicated heterodyne, super heterodyne sets, then the tubes became more complicated because you needed the special mixer tube and stuff like that. Okay, so we're going in. Here we go. We're going in. We're in. The tube is glowing quite a bit. Can't see it up in here because of the getters clouded the glass up. Okay, any shorts? No shorts. Does it work? Well, it works. Okay. So much for what I was saying. Well, maybe it passed. You know, it may pass the tube test, but still, it may be gassy. I don't know that I can do a gas check with this particular tube tester. Let's worry about it when we have to. Okay, so in you go. And then the this guy, 201. You notice the bulb is a different style, so this is a more modern bulb, but it really has this huge hot spot here, what I think is a hot spot. You know, what would that indicate? It's something fell over in contact with the tube inside it. I can't imagine that. If you hit this tube hard enough to make the insides come loose and fall around, you smash the glass long before that happens. Okay, so this is a 201A. This is a Rogers tube, made by the Rogers Corporation. It says 201 here. 7-point inspection, but it doesn't say Rogers on this anywhere. You'd think they put the... Wait a minute, what? Have we looked at this before? What does that say right there? It just says radio. 7-point radio inspected. Who did it? Maybe the seller. Maybe this is something the seller did? I don't know. Rogers. It's kind of a neat way the Rogers name is written on. Now, Rogers Corporation is still around today, but they don't make vacuum tubes. They don't make radios. As far as I know, they don't make anything electronic. They are Canada's largest, I think the largest, cable TV supplier, cable and internet supplier. They morph themselves. I guess Mr. Rogers saw the future, and he was right. Okay, here we go. We're going in. It's lit up, that's for sure. Again, it has that yellow color to it. Any shorts in this tube? Nope. That's normal. GM test. She's a good one too. Vacuum sealed. Okie dokie. Every tube tests good. I think we should try running this set. I think I've got all the stuff together. Only thing I'm lacking is an antenna right now. So I'll sort that out. And the next thing we will do, we'll try this set out and see if it actually works. Okay, since I have a huge number of new subscribers who may be watching, you may be a new subscriber. You haven't seen me start up a radio yet, so I'm going to explain a little bit about how I do it safely. It's not a big deal at all. So I have two ways to control the voltage being supplied to something like this. And one is this big box here, which has a knob on it. I can turn the voltage up and down. The output of this box comes to here. This is just one of those devices you can buy, you know, to tell you what kind of power you're using. Very, very useful here. Notice the ground pin is not connected, and this is a 2-wire extension cord. There's no ground being brought over. So this is actually an isolation transformer, and for some reason I cannot explain, I have another isolation transformer that this is plugged into. So super isolated from the power system ground. This stuff up on top here has to do with a radio antenna, nothing to do with the power. So, but the way I really control it is I leave this set to regular house voltage roughly, and I initially, when I'm starting up a project, I run the power through these light bulbs. These are old incandescent style light bulbs. They're not LEDs by any means. And the power before reaching the radio goes through those lights. What happens is if there's a big problem in the radio or the item I'm testing, like let's say there's a short in it, then the worst thing that can happen is the lights come on full tilt. And it's pretty obvious at that point that something's going wrong. They also provide a certain amount of feedback on the operation of a device during warm-up, of tube devices during warm-up, by the pattern of the glow in these light bulbs. And lastly, I can leave the light bulbs in the circuit. They'll drop the supply voltage here. I can compensate by turning up this and get a full supply, 115 volts on here, still going through the light bulbs. And then while I'm working, if something goes wrong, the lights will indicate it, and they, you know, these are right here in my face, so I don't have to look over at a meter dial or something, or a little tiny indicator light. These things will blast out into my shop, which is exactly what I want. So I find this system to be the best way to protect myself, or protect equipment really, when I'm doing this kind of work. You see there's two light bulbs there and two different wattages, and I can loosen one and then force the power all through the other light bulb to really bring on a restriction if I think I should. So right now both bulbs are in. So is that a good idea? Probably not. At the start we should probably start like this. Now this thing can draw, potentially, or maybe draw enough power to light this bulb quite bright. I may have trouble understanding if there's a short circuit or not. And I doubt there is a short circuit, but we don't know. We don't know what we're dealing with here. So, I also have an antenna. This is an outdoor antenna. It's fairly good. This is the lead from it here. And you can see I've got a couple of wires sticking out the back of the radio here. This is the ground wire. And this is the antenna wire, antenna input. Give the radio every chance you can possibly get. So let's put this over here. Okay, so these switches on the panel here, which with nothing plugged in, I'm going to operate them because they have a very characteristic sound. Hear that sound? So you hear that sound, you know I'm flipping one of these switches. So this is the master switch, if you like it. Just turn on this box. This box is nothing special, really. I had it, so that's why it's here. So with this switch off right now, nothing, there can be no power here. I put the switch on. Now this switch selects whether the power will go through these light bulbs or go straight to the device under test. So normally I would throw this down. You might have noticed a couple meters jump up in my shop, which is why is my camera overlit like that? You know, this big dark object is causing my camera to adjust. See that? Isn't that interesting? We'll open this up again and watch it. You won't be able to see that. We have excellent eyes. Our eyes are fantastic at seeing low light levels and incredibly high light levels at the same time. It's fantastic. Camera can't do it. Okay, camera not as good as a person. Biology wins again. So I think we're ready to go here. Now, just calm myself down. First of all, turn these switches off, you bozo. I left those in a bad position. Okay, we'll plug it in. So remember, there's no ground associated with any of this, except yes there is, because I've connected a ground via the antenna into the circuit here. I can't remember how the circuit is done, so does this really matter? If I were to stick my fingers in here in the power supply, oh my gosh, look who's here. Here he is. Here they come. They're waking up now. What are you doing? What have you been doing today? Not much. Okay, so trouble is coming. Him and his brother will probably be goofing around in here in a moment. Yeah. Okay, now we think about this stuff. This we can't know where the better spot is for this, so we'll put it in the middle one here. We should turn all these dials to roughly the same setting or the same setting, and I'm going to guess, I'm just guessing, this is probably the high frequency end of the band. I don't know though. Let's set them in the middle. 50, we'll set each one the same on the assumption that that's a good starting point. Here he comes. This is Bert here. So Bert and his brother Wally, we acquired both these cats from the same litter, so they're brothers. Mr. Wally, I don't want you. No. You know what? He's gonna try and eat that. I can tell. He's gonna try to eat that. So you're not gonna be on the bench today. At least not right now. Okay? You go and have some fun. Find your brother. Yeah, he's gonna stick his nose in here and get a whack off it like you wouldn't believe him. And you know what? It could kill my cat. I don't want that to happen. Okay, speaker's connected, antenna's connected, power's connected, lid is up, so we can see the smoke. Cat is coming back. The cat is coming back for another run. Okay, go around. If you're gonna do it, you know, curiosity. He's as curious as us about what's going on here. Hurry, finish up. Is it okay? Do you think it's going to qualify? What do you think? The world is filled with weird stuff. People do weird stuff. What is this weird box? Let me go find a mouse. Okay, I gotta take a little bit of a... Look at his tail. He can't hold it up any higher. He's a happy cat. These are both happy cats. All day long, they're happy, having fun. Okay, you gotta go down. You gotta go down, and I'm gonna have to kick you right out now. I'm kicking you right out. I just can't afford to have the cat up here with this switched on. I think it's too risky. Okay. So this is off. So with this switched off, we're going to apply power and find out if the on-off switch turns it on and off. They must have the... No, what I was going to say is stupid, so I won't say it. I won't say it. Oh, he's crying out there. Okay, so we're going to start with a very low voltage. So I am going to turn the voltage down with this. So this turn down in combination with one bulb, the amount of voltage delivered over here is going to be very low. But that'll tell me that there's a short circuit or something really horrendous going on. Will the radio operate? We're armed. Oh, volume control. So these rheostats control the heat level in the heaters. This one's controlling, I think, these last two, or maybe these three. And this one's controlling these two up here. So I've got them turned, what I believe is down, minimum. Okay, switch is off. Here goes the power. So you can see the light came on a bit. So the switch off, there's still power being drawn, probably because the primary is energized here. But it's enough power to light that light bulb a little bit. Is there anything going on in here? I'm going to have to turn off the big light there, and even this one, because if there is, it's going to be very faint, so I don't see anything. So with the low voltage setting, I'll cut the power here, pull the switch on, we'll turn it back on, we'll see if something different happens, which probably will. Here we go, power on. Looks exactly the same to me. This looks exactly the same. So that may mean that this on-off switch just doesn't work. Let's operate the switch with the light and the power on. So I see nothing. Could be the guy who did this, he knew what he was doing, and he knew that when he plugged this guy in, this thing is all live here. We could put a voltmeter on that. Why don't we do this? We'll be as cautious as possible. So I don't hear it humming. Well, I'm going to look for a high DC voltage here on these. So I mean, here's the positive. Where's the negative terminal? Yikes. Oh boy. Okay, maybe across these ones here. I can't see the bottom of the two big yellow capacitors, but I can see the bottom of this one. Let's see what's this set to? 600 volts. .3. So there needs to be a supply in here that's going to supply the heater current. This is probably it. He's probably arranged a DC supply using the same ground. Can I read this? Nothing's showing up at all. Okay, using what is probably the ground for these. There we are. 70 volts, so 35, so very good, 70 volts. So it looks like the power supply is doing its thing, supplying DC for the heaters. If you ran AC on the heaters on this radio, you would just hear a whopping hum come out of the radio. I'm pretty sure of that. You've got to supply DC. Okay, well, we're not hearing a thing. Can't put my ear up against the speaker, it's way up too high. But no surprise here, because we're operating with a very low voltage, roughly 50 volts on here. Okay, so I think the next step will be to jack up the voltage, and I'll do that by screwing in this other light bulb, and that's going to jack up the voltage a fair bit. Still quite low. The on-off switch on these radios often is just interrupting the heater current because when there's no heat in the tube, no current can flow. And even if you have high voltage batteries hooked up to these tubes, without the heater, they're open circuit. So just bringing that up because I'm just remembering these kinds of factors. I haven't turned these up yet. Well, that's probably why I don't see any heat. Okay, let's try this. I'll start turning up the heaters here, and I'm gonna put a camera here somehow so we can kind of watch it a little bit. Here we go. So we're going to watch this one tube right here. Okay, you know where the tube is. Let me move this over a little bit. So we're looking right in at the tube. Okay, well, I've got my hand on the rheostat. We're going up. I'm looking at all the other tubes also. Looking for anything at all. I see nothing at all. That white line you're seeing on the left side of the screen is a white piece of wire. So we've got this almost. Oh, guess what? They are heating up. You can't see it that way. You can see it this way though. I'll turn them down. Turning them back down. Wait a minute. That's all the way down. Okay, yep, they're going up and down. Okay, now the other ones. Let's see if we can get these ones going. So I have my hand on the other rheostat. Too much reflection here. Now I'm really in the dark. So now what you're seeing is the blue light of the camera. Okay, turning up the rheostat. We're looking down at the top of the tube here. No sign of heating. Going up, going up. There is a slight glow. I can see a glow. Okay. So we are running this with a lower voltage. Let me we'll put some lights on before I stick my finger into something unfortunate here. Okay. Okay, so what I've seen is I've seen a glow in every one of these tubes. Very low glow, and we are running the set with well under 100 volts still. So we're going to raise the voltage and hopefully hear something. How would I hear something? Fooling around with the antenna. The flickering is my light here. For a minute there I thought it was flickering in conjunction with this, but no. Okay, let's take it up a higher voltage here. So we have the two light bulbs in, leaving the light bulbs in, but cranking up the dial here. Going up. And supplying this with 95 volts. You can see the current is enough to heat this. Why is my light flickering over here so much? Okay, don't know why. Nothing to do with it. So 96, that should be enough to hear something, shouldn't it? Let me turn up the heaters here. They're all showing heat. So I'm hearing nothing, like no clicks or anything out of that speaker. Let's try this. This is the speaker wire here. Nothing from the speaker. Okay, so at this point we're operating now with 196, or 96, 196, what am I saying? 96 volts. We'll go a little higher. Oh, these tubes really turned on at this point. The light bulbs rather. So much more current is flowing now in the radio. I don't hear a thing. All tubes are glowing. Could it be the tuning? Wow. Where are we now for voltage on it? So we're 105 volts. You know, that should be enough. Well, we don't know what's going on with this power supply exactly. Go a little bit higher. But now there's just a little more voltage causing a lot more current to flow. Okay, back these down, back them up. Still not a sound out of the speaker. So, you know, I could twiddle these 3 dials, but what are the chances? It's just nothing. It's dead, Jim. Okay, I'm going to flip off. I'm going to turn the off. I'm going to flip this off and see what happens. Watch those lights and see if there's any change. They got brighter. How'd they get brighter? Let me turn this on. They did. That's backwards. That's backwards. Let me push this switch again. I'm going to watch the heater in this tube. Heater's off. Why did these get brighter? Why did they get brighter? They get brighter because there's more current flowing. They cut the heaters off, and more current flew. That's just backwards. I don't know how to interpret that. Anything getting hot? Nothing's getting hot. No smoke, no flames. Well, we have time to fool around here. That seems really difficult to me. How do you fool around with this thing? It's inside a wooden box. The bottom? Is there a bottom plate that comes off it? Expose everything underneath? Probably the case. That is probably the case. So I tip this guy up with the bottom. So these tubes, I believe you can operate them on their sides, but it's not good to do that. It's better to operate them vertically because the filament can droop, or if you have it on its side and you bang the tube, the filament can spring down and into the tube. So we're going to cut the power off completely. Turn some lights on here so I can see what I'm doing. Is there a entrance underneath here? Oh, there's some more information down here. I never noticed. I didn't notice that. Let's read what it says there. Sorry for the camera work. Well, it's a warranty anyway. I mean, we can see that. And this receiving set number 7570. Mounted. Look at this. They actually sign their names to it. I have a real bugaboo about this idea of sign your name to everything you do. Boy, would this be a better world if everybody had to expose their names. Mounted by, wired by. That's probably tested by, inspected by, packed by. Wow. They're keeping track of everything. In case something or other, please return something or other. There's a nail sticking out of this. Is that a nail? What is that? You just nailed this on. The 233 is written with a different pen. Maybe what's happening is as this was being assembled, different people were writing on this tag. And what's that right at the bottom of this? Again, sorry for the July 1925 when they printed this. Read instructions carefully before connecting batteries to set. Something or other, something tubes. Be sure all wiring to batteries is probably correct. Tubes consuming not over a quarter amp must be used. And then up here, damaged by misuse. Okay, just the warranty details. Well, what we really have this tipped up for is to see if we can sneak our way into the bottom, but it sure doesn't look like that at all. Let me put on my big light here. So we have these. No, you know what? This is dovetailed or it's fit right in here. This is not coming off. This is a solid box. How do you get at the stuff inside? That's a good question. Take this whole front panel. Maybe you pull off the front panel, the whole radio comes out. That's probably what it is. That's probably how this works. That's probably the case. Probably take out all these screws, and this whole piece just slides out. Wow, it can't be that simple. You'd have to remove the tubes. They won't fit out. The rest of it, I think it's made just to slip out through the. Otherwise, how could you possibly work on this? Now wait a minute. This is so often these radios were built on. Well, these radios were built on a board, and they would be called breadboards. You've probably heard of this, and the term is still floating around today and used for electronics. But back in the day, you really were using a board that you used to cut your bread on, because how many people had a board of the right dimensions and the right quality, and you build your radio on top of this breadboard. This radio. Ooh. Okay, learned that lesson. I'm looking to see if there's like a board going under there. Excuse me, that would slide out. I haven't got a clue. Looks like the only option is to take off this panel and hope the whole thing slides out. Yeah, it might be a large metal frame up in here. I can't quite see. Yeah, I see it now. So there's a metal frame running right across, and then there's plates coming out, and then the parts are mounted on these plates. And there's 3 of these. It looks like three plates. Okay, so power's off here, right? For sure. Turn this back like that. So that's going to be it for today. Tomorrow we'll look at pulling the guts out, looking them over, and trying to assess or trying to figure out, how do you even test this? For all I know, this radio worked. I just didn't get it tuned sufficiently to make sound come out of the speaker. I don't think that's the case. I think there's something more going on, but I don't know. So thanks a lot for watching today, and like I say, tomorrow we'll pull it out, just look it over, see if we can get it going. Thanks a lot for watching today. Have a great day.